Welcome back. So we go on with our second session on using satellite data to monitor geo-hazards and infrastructure. The session will be moderated by Linda van de Duivenbode from Groundstation DotSPACE. So Linda is a founding member of DotSPACE Foundation, an open innovation network focused on education, exploration, and creation by means of remote sensing technology. She's been involved in the space sector since the 90s, and she's been working on mobility and energy projects, helping to bring tech solutions to market and building bridges between the space and non-space sectors is one of her passions. So, Linda, thank you so much for being here with us, and the floor is yours.
Thank you, Gatia. Welcome everyone to this next session. Now, cities need to be resilient to geohazards. Geohazards, think of floods, slopes, and earthquakes. Soil movements are a major threat to cities' infrastructure and inhabitants. Worldwide, cities are looking for solutions to better face and mitigate the effects of geohazards. This session will present two emerging applications based on satellite data and signals that can support cities to face threats linked to soil subsidence. Now, as before, during the presentations, you can send your questions through the questions box. I would like to turn to our first speaker and ask that he turns on his camera, microphone, and start sharing his screen. And I would like to welcome Mr. Pablo Ezquerro Martin from the Spanish Geological and Mining Institute, IGME. Now, his presentation is about assessing geohazard vulnerability of cities and critical infrastructures. Pablo, can I remind you that you have 15 minutes and I will keep time. The floor is yours.
Well, good afternoon. First of all, I want to thank you for giving us the opportunity to present the working methodology and application of the eShape project Pilot 3. Its name is Assessing Geo-Hazards, Vulnerability of Cities and Critical Infrastructures. The objectives of our pilot are to increase the use of multi-mission Earth observation derived products and services to assess urban vulnerability and geohazards, systematically map vulnerable urban areas and critical infrastructures threatened by geohazards, and raise the awareness and train key users and decision makers on the use of the Earth observation derived products and services, increasing the urban resilience against the geohazards. Our methodology to reach the objectives is based on 4 products that we have designed with different levels and requirements. These products are designed to be useful for technical people in the case of the first two, and non-expert managers and decision makers, the third and fourth products. First and second products are the raw INSAR results and the INSAR validation report, and they provide the domain displacement data information about the performance of the processing and a first assessment of the possible active geohazards. The active geohazards report is one of the main advanced products where the raw displacement data are analyzed to identify the active deformation areas through a statistical analysis of the INSAR point cloud. Then, crossing them with the geohazards data, the specific geohazards is defined, and at this point we have designed specific methodologies for landslides and subsidence. We are also working in a methodology for active and non-active mining areas, but they are not yet finished. The last main product is the Vulnerable Areas report, and this product is supported by cadastral and damage information that allows to identify the vulnerability of the buildings based on the INSAR displacements. In order to show better the possibilities of this methodology, we have applied it to the Murcia City and Alto Valentín aquifer systems, an area affected by land subsidence due to groundwater extraction. This example has been used to co-design the methodology between the Spanish Geological Survey, responsible of the proposed products, and the Groundwater Authority of Segura Basin, receiver of them and responsible of the monitoring and exploitation of the basin water resources. Our stakeholder proposed us to develop a product that helped them to improve the management of the aquifer system. For us, the challenge was to provide them the specific information that they required to monitor the Segura Basin during the pumping periods, correlate the detected surface displacements with the groundwater changes, identify the influence area of the pumpings, and determine the accumulated displacement and their impact to the buildings. And make that, this is an important point, make that information useful for the exploitation strategy. In order to do so, we designed the previously presented products that I'm going to explain better with the outputs that we have obtained. First, a little bit about the INSAR data. Usually INSAR results are highly dense point clouds, but depending on the processing resolution and vegetation typology, they can show a clearly deformed area or only a small and slight displacement, also depending on the trigger that is producing those displacements. In this data also can be clustered to improve their management, and this is one of our first products. Also, it's important to deploy a additional monitoring system to validate the products. This kind of validation needs of contemporary and continuous dataset of GNSS permanent extensions, but also can be performed using leveling data or other kind of, let's say, campaign measurements based on GNSS data. These validation products will provide the root mean square error and the relative error of displacement velocities and time series. If the GNSS or leveling data are not continuous or not contemporary to the INSAR the validation, it's only partial, but it's still important, especially for the interpretation of the results. The active subsidence third report is composed by two different steps that define the area of influence of the extracted activities and the temporal evolution of the subsidence. First, using extraction rates and the position of the wells, a first estimation of the most susceptible areas can be done, as you can see in this picture, with this blue line show that the areas that we think that are going to be more impacted by land subsidence, and then when we have the displacement data, we can see if it's correct or there is another triggers that are provoking subsidence. This area of this influence area, it's also a vital parameter for groundwater management and differs depending on the extraction periods, as you can see in these graphics of the right side. For example, in the upper one, we can see that there is only subsidence in the first 2 kilometers because this extraction was quite it's only 3 months, but in the bottom one we have a longer extraction period, and the affection to the land surface was wider, reaching the 3 kilometers. The evaluation of the groundwater and subsidence time series give also us the possibility to identify the extraction and recovery periods and the inflection of subsidence. The correlation or not of them describe the behavior of the aquifer system under extraction stress, especially useful to improve its management. In this case, we show two different behaviors. In the center of the basin, we show this behavior with a continuous declining trend of the land surface in the red time series. And in the edges of the basin, we only see the subsidence during the last extraction period. This is because the center of the basin was exploited during several extraction periods, and the external part of the basin only was exploited during the last one. With this information, the Water Management Authority move their extractions and change the exploitation strategy to affect less to the land surface, but also to the impact in the groundwater levels. The Urban Vulnerable Areas report is one of the most complex products because specific information is needed, and usually new damage detection campaigns are necessary to plan. Due to that problems, two different levels has been described. The most complex one is based on the fragility curves, which are empirically built, combining INSAR data and field data to evaluate the potential damage on buildings affected by land subsidence. Once calibrated, they provide the probability of some level of damage for certain building displacement. We can even calculate expected economic losses if enough economic data is available. The other level only requires cadastral information and combines specific data of the case study in order to define displacement velocity and accumulated displacement thresholds to evaluate the damage vulnerability of each building. All those products applied to the study of an area affected by land subsidence like this help to understand better the dynamics of the aquifer system and adapt the exploitation strategies. Using the co-designed products, our stakeholder, the Segura River Water Management Authority, has adapted the pumping strategy, moving the extraction to the less affected areas, taking into account the wells levels and the subsidence time series during the drought periods, and reducing the effects. Also, the building vulnerability maps are one of the main thresholds to cut off the pumping in the area, because the damages to the structures were detected in the area during previous extraction periods, and now that they are one of the most important problems, and they have to check carefully if the extractions are generating new damages. And that's all. Thank you for your attention, and let me know if you have any question or any comment.
Thank you so much, Pablo. So I think while Grazia's preparing a poll about the presentation, there's a question. Carl, in his presentation at the beginning, mentioned that an authority has a budget X and the service may come at price Y, and if they're not compatible, then it's difficult to buy. Have you looked at the cost and the budget available for this service to become operational?
I had a shutdown in the Wi-Fi. Could you repeat the question?
Okay. So have you looked also at the cost of providing this service to the groundwater company or authority and their budget available for acquiring such services to see if it could become an operational service?
At this moment, it's we have carried on two campaigns. We work in let's say a campaign mode. We work with them if they have a extraction campaign, but I don't have the numbers now about which is the cost of the service. I'm sorry. I can provide you with the information, but not now.
Okay, all right, thank you. So I think there's now a poll about this presentation, which asks, do you think that the service presented is useful? So 3/4 of you say that the service is useful. I guess the easy to use, unless you've used it, you wouldn't really know. Reliable, cost efficient, again, we don't really know what the cost efficiency is, and innovative, 17%. So it seems actually quite in line with the previous poll responses. Was there a second poll question, I think? Yes. Would you like your city to invest in this kind of solution to better manage the infrastructure? So you now have a chance to answer yes, no, or I don't know. I suppose it's always also a question of knowing how much the cost would be and would it raise taxes significantly if your city did buy it. But based on the service itself, the majority answer is 60%, whereas 40% says I don't know, but there are no people who would not recommend buying it. Okay. Well, thank you very much. Pablo, we're now going to second presentation today, which is a joint presentation from Annemarij Kooistra from the Department of Engineering in the city of Amsterdam, and Patrick Stoppelman, who is the Director of Business Development of company SkyGeo, both in the Netherlands. Again, can I ask you both to share your camera, and the first person to speak, which I think is Annemarij, also your microphone as well as your screen. You also have 15 minutes between you for your presentation, and the floor is yours. Thank you.
So hi everyone, here is a combination of Municipality Amsterdam and SkyGeo. We have a presentation. I cannot deal with the presentation because I didn't open it. This is not the first sheet. This is about the application of INSAR. INSAR in a city environment. Annemarij, do I have to do it? Can't hear you, you're muted.
Yes, Annemarij, sorry, you have to unmute yourself through the interface. There's a micro. Okay, you're muted.
Can you all hear me now?
Yes.
Yeah? Yeah, it said that the organization muted me, so I couldn't unmute myself. But if you can all see the presentation now, thank you for inviting me to...
We cannot see the presentation, Annemarij, because I think you shared your screen briefly, but then that...
Yes,
now it's back.
Yeah?
Yeah, excellent.
Oh, perfect.
Thank you.
Yeah. Thank you. I'm Annemarij Kooistra, and I work for the city of Amsterdam. And in Amsterdam, we are working on a big program on bridges and quay walls. We have a very nice historic city center with a lot of canals. And we see that with the increasing traffic use, we have a structural overloading of the bridges and the canals. And we also have a period that the maintenance of our infrastructure is neglected. And therefore we need to catch up. And we started a large program in which we intend to inspect and reinforce or renovate 800 bridges that we use for traffic and 200 kilometers of quay walls, inner city quay walls. This is a very, very large scale, and we are used to handle 1 or 2 bridges and a few hundred of meters of quay wall that we renovate. But with such a large program and also information that is needed, that we said we need to innovate in the ways we are dealing with this. The innovation we do on many things, and within this innovation we work with the universities and other knowledge institutes, and also with businesses, because all the innovation that we want to develop, that needs a business model too. And as a city, we invest in this innovation. Well, one of the things we want to change and is how we get data from our existing quay walls and bridges. And deformation of these structures is very important. It's if there is a lot of deformation, then that's a sign that the quay wall or the bridge needs to be renovated. And that's why we also look at satellite data to use. And therefore we have a partner since 2017. We work with SkyGeo, and this is where Patrick can tell you something about SkyGeo.
Thank you very much, Annemarij. So this is our company. This is a little photo of our presence in Delft, also a small town, old historical town in the Netherlands. I think what's the main message here is that we come 12 years ago. We are a spin out from University of Technology in Delft, and we've always had also ties with the community of research, but nevertheless we are an organization that fulfills requests. So let's go to the next sheet. I can't do it myself, so someone has to push the button. Annemarij, I guess it's you.
Sorry?
No, this
Patrick, when we started off in 2017, we first did an assessment on a lot of our bridges in Amsterdam. We looked at the scale of Amsterdam to find the deformation data of the bridges. And we also presented the results already in this platform in Ghent on a workshop over there. By that time, we found out that the data is promising because it's useful for risk assessments. But we also saw that there would be chances for further development to get even more information out of it. But we started to monitor the houses of Amsterdam. Of course, we need to renovate bridges, but with the renovation of bridges and quay walls, we work very close to the old houses along the canals. And there are risk that there will be deformation induced by the reconstruction works. And the satellite data proved to be a tool to monitor the deformations of the buildings in the proximity of the works. And with SkyGeo, the TU Delft and Deltares, we did an investigation on how we could improve those data. And Patrick, I think you can explain that better than me, what you did in that survey.
Thank you very much. So here becomes a little more technical. So I think the first important element to understand is that we are not working with open data from Sentinel. The sort of the level of detail of density and the reliability in terms of XY positioning is such that we need a resolution of 3 by 3 meters, and the Sentinel resolution is 5 by 20 meters. So that's not applicable for sort of a fine density that you find in typically historical city centers. So that's the data we're reviewing. And I think one of the challenges we made, and this is also where an INSAR provider makes a distinction between, let's say, open source and managing their own source, is we were able to improve coverage by a factor of 5 at least. And so by doing that, and that was tested by an independent institute by the name Deltaris, it's something like a water inspection. It used to be Water Inspection Institute, and they've become now an independent organization. And together with the University of Delft, we were able to improve the coverage. And as a result, we cover almost all building blocks that are, for example, in the boundaries of the Amsterdam municipality. It was sort of tested at the accuracy, and this has to do with the XY positioning and the Z, the height leveling. That was also a sufficient accuracy to also compare to traditional measurements. And this is, of course, very interesting. So there's a lot of traditional measuring still going on. There's a lot of money spent also in many places on traditional leveling. And it turns out, and this has been tested again independently, that the traditional leveling has also a lot of backdraws. You're sometimes missing seasonal effects, or that's sort of blurring your picture. You lose measurement points because bolts get whatever eliminated. And so this turns out, INSAR turns out to be also very reliable, recurring data provider. And we've been doing sort of a mix of long-term and shorter-term measurements, by which we were better able to make distinctions, for example, also in tilt. And this is very interesting for renovation projects like in Amsterdam, because if you conduct works on the street level and on the quay wall that is in front of a building, you're touching, in fact, a part of the foundation, the stability of the ground that is there. And if you take something out, you're changing it, and it gives already a direct effect in the tilt. Okay, let's go to the next sheet. Yeah, so we also produced, you see in the left picture, you see a clear difference. It's very small, but here you can see that's already a clear distinct difference between many buildings in what seems at first sight a building block from the same period. And so these differences already make it interesting to do an alertness that is based on real data and not just on an inspection of a facade, which was previously the case. And there's also all kinds of reporting, because if we talk about a massive number of houses, you need to think about how do you do your administration? How do you create files? And so part of this file administrational part is building a report in which this is an element. So these are all more practical matters that play a very important role if you scale up. Next sheet, please. Yeah.
So this was our investigation on the building blocks. But then we went back to the bridges. So what we learned in looking at the INSAR data for the building blocks, can we also use that to do a more specific investigation in the deformation of our bridges? In Amsterdam, we have many bridges that are founded on wooden piles, and some of them are even 200 to 300 years old. So there is a degradation of the wooden pile foundations, and also bacteria can make the foundation weaker. And this shows on the surface by deformations, and therefore we thought it's probably a good tool to use the INSAR data to find out which bridges might have a foundation problem.
Yeah. So what is interesting about this project is, in part, it's also to fill a gap of, let's say, limited information. So there's some extra, let's say, pressure or intensity to this project. And so the first thing we did, we got a list of 260 bridges out of the 2,000 that have wooden piles. Now, what is interesting is that over the past year, I learned through other projects that wooden piles are used in many, let's say, North European countries. Also in Boston, for example, I came across a project where this is being used. So this is a widely applied technique that is used up until sometimes the 1950s, 60s. So what we did here is we used again TerraStar X high resolution, and we used two looking angles. I think it's important also, two orbits to understand. So we were able to do both, and also look at the horizontal element. Two conclusions on the lower end: all bridges have measurement points. So this is very interesting. It was a question. There's sometimes trees, big, beautiful old trees standing around it. Only two bridges in the park of Amsterdam, we have no points or one sort of weird point, because those small bridges are covered by trees. But in fact, it's a very high return that 258 bridges have coverage. So this is just a zoom out. Let's just start zooming in. And the next sheet is an excellent example for that. Yes, so here you see a layout well spread over the bridge. This is, of course, very interesting. Some points appear in the water. This has to do partly that we decided to take a little buffer. It has also to do with the XY 1 meter standard deviation. So these points are considered all to be having a relationship with the bridge. Sometimes there's also wooden poles that sit in the water in front of a bridge, and that can actually be, there's a metal cap on it that can function as a reflector. Now, they're well spread. Nevertheless, this is still a blurry picture to find a conclusion. So we go to a next sheet where we can see we started to fine tune the sensitivity. And this has more to do is how short or long and how well should you look at the movements of the bridge. So this is something that is still ongoing. This is very dependable on many in situ, many local circumstances. This is something that we also specialize in, and that we do in collaboration, in this case with the engineering department. And so once we defined the sensitivity measurement highlighting the difference, we go to the next sheet, please. And then we introduce the constructive elements that a bridge contains of. And then we start seeing some interesting differences in movements of elements of a bridge, and this is part of getting a sort of a first line risk assessment based on 10-12 years historical analysis, which is quite a long time. What's going on with these bridges? I think I have to add is that these bridges are all, there's heavy traffic on it. There's trams, which is in a city train. There's buses, there's lorries with concrete, with tourists. So all these bridges suffer from increase, and there's differences both in the constructive elements and also per bridge. So I think we should go to the next sheet. Some conclusions. Sound coverage, minimal number of bridges with 0 points. Reliable, this was a main topic, of course, reliable measurement points on a majority of the bridges. Differential settlement of abutment and between abutments is detectable. There is still interpretational value for the risk framework is further developed. So in other words, how do you assess 260 bridges, and how do you get a right order and a right risk assessment? INSAR appears as a useful instrument to conduct a baseline. The expectation is that the data may fill the information gap, and the development of the settlement monitoring is an instrument that will be further assessed. So that means that we are identifying if regular updates also give sufficient indication of the movement of the bridges. I think this part concludes the bridges, but we have still more, Annemarij, because Amsterdam is a great city. It is moving.
Yes, Patrick. We are still in the in working on the bridges, and we think it's very promising, and we made very big steps in using it for our challenges in Amsterdam. But there is another issue, that we are not only working on the bridges, but also on the canal walls, on the quay walls. And in September, it was very clear that this is a very urgent problem. One of the walls collapsed in September, and fortunately, there were no casualties, but this is very risky, and we take this very seriously. So we asked some parties to do a rapid assessment on what can be learned out of this failure. And one of those things is, could we have predicted this to happen? And SkyGeo was already working on the bridges and was working on processing the data, and found out that they also had the data of this particular quay wall. And therefore we thought maybe we can learn something out of this, how also this could be used for the quay walls, and maybe even to predict situations like this, so that we have an early warning and can prevent a failure like this. Patrick?
Yeah. So Linda, we're going to the final sheet, so don't worry too much about the time. So in hindsight, so we were never asked to monitor this. In hindsight, we looked in March, it's a cutoff moment for the bridge study. We looked also at this part of a quay wall, and this quay wall collapsed, just so that you get the timeline right, collapsed in August, September, end of August, begin September. And so here, this is a first image where you see increasing deformation was visible. Yet, what is the right moment for action? That's the question. And let's go to the next sheet. So yes, over the past 4 years, a difference is being observed. Here you can clearly see we put some extra sort of line measurements in here. I think the real challenge here is not only the interpretation, and so taking at the right time the action. I think it's one of the most still challenges in its kind. But it's also, if you have 200 kilometers of quay walls, how are you going to get signal, INSAR signal, because the quay walls are very pretty, but also many, the greater public of Amsterdam makes use of it. There's cars, there's living boats, there's all kind of stuff. And so how are you going to convert it? So I think this sheet is sort of an next level challenge that we will work on. And the first question here is the signal density. What are we going to get? If you see, for example, this quay wall, you see great trees. They're very pretty. They are at least 100 years old, but they will blur the signal. There's parking places that can cause confusion. There's narrow canals. There's some very narrow canals, and there's very beautiful barges or living boats where people live on a canal. Very romantic. And once we finalize the signal density, then the next thing is, of course, signal interpretation. So for 200 kilometers, how are you going to manage the risk matrix and false positives? I think there's one more sheet, or are we done, Annemarij?
We are done. I thought I had an extra one, but yes, this is the challenges that we face for using this for the quay walls. They are the largest, but we think we made some major steps in monitoring the building blocks and the bridges, and we think we can use the tools that are made now. Our next step will be how to use it for the quay walls. For the city of Amsterdam, and especially in our program on the bridges and the quay walls, so we are glad that we can use these new kinds of techniques to face this large challenge. So are there any questions for me or for Patrick?
there will be another poll again to see how useful people find the service. One question I have is, Annemarij, I am aware that you launched a small business innovation research challenge recently to monitor the key walls and the bridges. And one of your ambitions is also that such a service would be able to roll out to other cities. I have two questions. One is, are you aware of any pooling of requirements or market intelligence for a joint procurement so that you can spread the cost of such a development over multiple cities? And since the topic of this workshop is how can we move services from innovation to operation, are you there yet in operation, or how far are you? And that's probably a question to both of you, this last one.
Well, the last one is, I think it's a bit confusing that I can't see you. Sorry.
I haven't changed. I'm still the same.
No, but yeah, I see my presentation now, but that's okay. I'll just talk to the screen. Yeah,
Talk
that's
to the hand.
Thank you. That's better. Thank you for that question. Yes, we have this small business innovation that is now tendering. So, but we are looking on a broader scale. There's not just monitoring with the satellite data, but also using other techniques. I think the satellite data, it's very good to use that, because then you can also look back in time and see the development of deformations. The other techniques, if you start now, you need to build a database from scratch. And I think that's why satellite data has an advantage in here. As I showed you that we worked on how can we use it for the building blocks, for the bridges, for the key walls, and all those three things, they are on a different level. I think for the building blocks, we are in the implementation phase, so we are really using it, but also trying to get a place for it in our policies, that it is used and accepted on that level. For the key walls, it's not ready to be used in operation. That's still development. And for the bridges, we are close, I think.
Yeah, maybe adds an element. So, what is a challenge, and I think this is in part also you can find in the challenge that Amsterdam put out, is are you going to combine various techniques? So we are in projects where, for example, INSAR is now steering traditional leveling. So leveling goes only to places where INSAR doesn't work. We do projects where we have something with soil moisture. And so there's a combination of sensors or measurements that is a technical challenge first, but also an analytical challenge. How do you get the right values? So that's, I think, one element. There's, of course, the whole chain of companies that want to solve all the problems with artificial intelligence, self-learning systems. I think there's much more information, in-depth information, also still required to get these systems effective. And in order to, let's say, to spread this service over more cities or more towns, I think the limitation here is that we use high-resolution TerraSAR, which is a commercial product. This is not freely available. I think there's also projects going on where similar projects are organizations trying to get a similar like result with open data. I said at the beginning, it's a different resolution, and that has a direct impact on the effectiveness and on the alertness and the risk level that you can achieve. So this is a restriction that I want to make clear to everyone that is seeing this. So that's a form of limitation. And so, for example, in the Netherlands, okay, we manage a whole bunch of towns where we have this data, but it's not anywhere in the world. I can even add to it, it's not anywhere yet available. It's foreseen that there will come a change in a few years' time when all the American satellite providers and also European will open up all satellites, sensors, but that is still not in place.
Okay. All right. Thank you very much. Thank you. over to the
Did
poll.
you get all your answers? Because I think there were like 3 or 4 questions.
Yes, probably not, but it would need another session, I think,
Okay.
to really get into the depth of it. So now we go over to Grazia's polls because we're already running late again.
Okay.
But thanks very much. Right, so usefulness, so high, 83%. Easy to use, I guess people don't really know. Reliable, so it seems that the validation by an organization as Deltares adds to the sense of reliability. Cost efficient, probably not known, and innovative, also quite high, third. That's interesting. The second poll question, I think, is similar to the other ones. Would people recommend city to invest? I think having looked at the quay wall collapse in Amsterdam, I would certainly say yes to that, but I'm not able to answer the poll myself. Okay, 56%, 44 wouldn't know. Again, we don't really know, of course, why people give these answers. So maybe that could be a follow-up to investigate, because that's close enough to be level. All right, well, thank you very much. That concludes this session on geohazards. And I would like to give back to Grazia for the introduction of the next session. Thank you, Annemarij, Pablo, and Patrick for your contributions.